Well, let's start from the last class. What we have learned, we are here, right? We have and we are trying to understand the N MOSFET. No, sorry, NJFET, right? And I explained here in this diagram that the source in the bottom side, then upside, and why this is the depletion region is bigger, right? I already mentioned, because in here the voltage in the upper side is bigger than the lower side. On the other hand, the right and left, the voltages are same. So the voltage difference between this point and in here, and this is two red points, are bigger compared to the voltage difference between the bottom, these two. And this line and this line, the upper line voltage difference is bigger. That's why the depletion region is bigger. And the voltage, and whatever the voltage difference is the reverse bias. That's the reverse voltage, because reverse voltage means the negative voltage at the P terminal or zero. In this case, is there is no voltage at the gate, so that means there is no voltage at the P terminal, but negative voltage on the, no, positive voltage at the N terminal. You see, the positive voltage is connected to the body of the transistors. So this body means this sky color part, that is N type. N type means full of electron. However, this electron, full of electron, should be connected to the negative terminal, but in here is connected to the positive terminal. That's why the voltage is reverse bias voltage is higher. So the depletion region is higher in the top compared to the bottom. And if we increase this voltage, this supply voltage VDD, and then gradually going up to this point, and will be will be touching each other, and the two depletion region from left to and right are coming close to each other and will touch at some point, and that phenomena is known as pinch off. And once the pinch off is happened, then after that the current will not increase anymore. But before that, the current used to increase depending on the voltage. In here you can see this is the IV characteristic curves for the JFET. This is the voltage in the x-axis. So that means that we are increasing the voltage from 0 volt to gradually increases. And when we increases from 0 to this is BP, and the current starts to increase, you see almost linearly increasing up to the highest point. And at this point, this is a pinch off point, and that is called the VP. That means the voltage at pinch off. VP means voltage at pinch off. So, and that time the current will be the maximum, and that is known as saturation. And the current, this current is actually we indicate by using ID, because the drain current, and because the current is going through the drain, and there's drain current. But at this point, the ID become fixed, and is a constant value, almost constant, but is sometimes a little bit fluctuations are there. But is we can consider this a constant voltage, constant current, and that is represented by IDSS, the drain current for saturation. Right? There are double S for saturation. Right, and this I say V and VD, the VDS is in the and this x-axis, and ID on the y-axis. So now this is so after the pinch off, the current is constant, but before pinch off, the current is gradually increased, sharply increased. That in here says, and this equation can be represented by a mathematical formula, the voltage. But maybe before, okay, now, okay, before we go to the formula, what we can do, think about the gate voltage. In here, what we have done, we did not apply any voltage at the gate. I think here we apply. You see the VGS equal to 0. So that means 0 voltage is applied here. Now, and in this only this voltage was changed. VDS was changed from 0 volt to VDD. The highest voltage is VDD, and gradually changed, and then this phenomena we have seen that the depletion region starts to increase gradually, and the current also gradually increased, and then some at certain point it stopped at a constant value. But now we can see what will happen if we change the voltage at the gate. Right? So far we have not done anything of the gate voltage, but now we see here in this case, right, we are increasing what we are doing here now. And here you see the gate voltage VGS is negative. Look carefully. VGS is negative. What does it mean? The negative voltage is applying at the, you see here what is in the gate. Gate is connected to the P in this left P, and also you see here is going here and going to the other side of the P. So that means this negative voltage is connected to the P terminal of both sides, this side, left side, and right side and left side. So that means P type material, right? P type silicon is connected with a negative voltage, right? With a negative voltage. What does it mean? P type P type terminal is connected to the negative voltage, right? And N type terminal. This is N. This is N, and the body is N, and N is connected, and look at here, this N terminal here is connected to, you see here, positive. N is connected to the positive, and gate terminal P is connected to the negative voltage, right? So just like the same as PN junction is a P, N, so P is connected to, you see P, this P is connected to positive, connected to negative, you see negative voltage, so is negative voltage, negative. And N is N, you see N is connected to the positive. N is connected to positive. What does it mean? That means this, right? This is reverse bias again, right? Negative voltage in the negative terminal, positive voltage, no, negative voltage at the P terminal, positive voltage at the N terminal. That means again reverse bias, right? And you see there is no power supply here, right? So if you do this, so again reverse bias. So then again the depletion region in here, you see the depletion region will gradually increase, just like the before the previous operation happened, right? In here we applied 0 volt here, but we changed the voltage in this, applied 0 volt, but we changed this voltage. But now we are not changing any voltage on the other side. We are not changing voltage here, right? In here you see, we are not changing, is fixed voltage. VDS is greater than 0. Some voltage is fixed here. In this voltage is fixed. However, this voltage is negative. So when you apply negative voltage here, that means this reverse bias again, and again there will be there will be reverse bias, and the same thing happen, right? If we increase the minus, if we increase the VGS -1, -2, -3, gradually increase the negative voltage, this depletion region will also coming close to each other and will touch each other, right? The same thing happen. So in here is, and the characteristic curves, and based on the VGS, let's say this is a VGS equal to -1. If we VGS equal to -1, then the curves will be like this one. You see this, the middle one, right? In this one, no, not middle one, this one, right? And when VGS equal to 0, that means that the first operation, that will be the maximum, that will be the highest one. The top one is here. VGS equal to 0. And now when we increase the VGS equal to -1, then it will go a little bit downward. You see this one moving down, And if you increase the negative voltage, VGS equal to -1, and here VGS equal to -2, it will go further down. Right? VGS equal to -3, further down. Right? So now, so depending on the value of VGS, these characteristic curves will be going in like almost parallelly, but in a different place, right? Different what's called a different height. Right? Now, what will happen if we place a VGS equal to positive? Let's say VGS equal to -3, -2, -1, 0. Right? If we consider that VGS equal to, let's say, 3 volt, right? 3 volt and +3. So what will happen? +3 হলে কিরকম হবে? It will go up and then go up and it will go like this.
Sir, upwards যাবে স্যার।
Hmm?
Sir, upwards যাবে আর কি, positive 3
Upward, right? This one, right? I have done drawing, right? This one, right?
Yes, sir.
Yeah, and if we increase further plus, there will be more higher. Right? So this is the characteristic curves. Any question about that? How to draw the characteristic curves? Right? Because we need to analyze these curves later on when we have to solve some mathematical problems. And one thing, if you look, what about the pinch of voltage? What is going on with the pinch of voltage? Let's think about the pinch of. Why is the pinch of voltage for VGS equal to 0 volt for this one? This is the standard one when the VGS equal to 0. That is the standard one. And you see the pinch of starting from here, right? So that means that is the pinch of voltage, right? So, and if you go down, here is the pinch of voltage. You see, this is the pinch of voltage here, right? Around 4 volt, right? But let's say in here, in case of, okay, we'll clean this. Let's say this one. So clean, and let's say VGS equal to -1. How much will be the pinch of voltage? You see, look, the pinch of voltage is not here. Pinch of voltage is a little bit before that, and the pinch of voltage will be around this, right? Maybe if in case of 0, if it is 5 volt, in this case it will be around 4 volt. Right? Understand? So when the VGS is decreased negatively, then the pinch of voltage also decreased. And see, for this one, pinch of voltage is here, and in this one, pinch of voltage is here, right? But if we increase the voltage, let's say, this is my handwriting, so hand drawing card. If we make it a VGS equal to some positive, then the pinch of voltage will be higher, right? If we go up, it will be like it will be like here. So it will be it is not a straight line, but anyway, it will be around here, and this is more than the 5 volt. So this is the way actually this we can draw the different curves. Different kinds of curves we can draw, or we can get some currents or voltage from these curves. For example, let's say saturation current, right? We have seen that for VGS equal to, when VGS equal to 0, then how much is the saturation current? Is IDSS is around, this is curve is there, is 8, right? Around 8. What is this? Oh, his scale is milliampere. The unit is milliampere. So that means when VGS equal to 0, so the maximum current or saturation current is IDSS equal to 8 milliampere. Right? But when VGS equal to -1, look here, when VGS equal to -1, the saturation current line is here. And this is the saturation current at this point, and this is 4.5. This is 4.5 milliampere, and this one is 4.5 and 4.5 milliampere current here. So is further down, and if you could get it VGS equal to -2, it will be further down. It will be around 2 milliampere. And if VGS equal to -4, it will be just 0.5 milliampere, right? So there are from this curve, actually we can get different values, and actually we will need it when we solve our problems. Then we use this curve, right? So now there's a formula to calculate. Okay, so before we go, oh yeah, formula is here. So now if you look at these characteristic curves and you see the first portion before going to the saturation, this one looks like a linear, right? This one, or you can see the other. This one is better understanding. You see, from 0 to up to this point is almost linear. And if it's a linear, so where we get the linear curve? And in this side is voltage and another side is current, and we know that very well. Say if we have voltage is here and current is here, right? So, and if we get a line, constant line, so what is this line for? And what is the relation between this line with the I and V? R. R is equal to VI, right? So it's a resistive curve. Resistive curve is always constant. If it is constant, that means it's a resistive curve. That's why this is called voltage controlled resistor. And the first part is actually voltage controlled resistors, because this is controlled by the voltage, right? We are right in here. Now we are using some voltage, either voltage at this point or voltage at this side. We are using in order to control the current. So that is called. That's why it says we are controlling the current, but this one is a constant. The resistance remain constant. So that it says voltage controlled resistor. And there is a formula to calculate the drain to source resistance is equal to R0 divided by 1 minus VGS and divided by VP. You say VP is the VP. What is VP? VP is here, the pinch of voltage here, and VGS in here already on this line, and R0 is a constant value. Is what is the R0 value? It says the value R0 is a constant. We did not say any value here. It should be given. Okay. Okay, it should be given. Okay. Anyway, so this is a constant divided by 1 minus VGS by VP whole square, right? So this is the total, right? The operating principle and the characteristic curves for the N-type JFET. And now we can move to the P-type. P channel. P-type means P channel is just the opposite, right? Just opposite. What was the N-type? The body was N-type, right? Now you see, compare this, compare this body. Here you see the body, the rectangle, this is the body, is a rectangular shape. This is the ash color rectangular part, and that is a P-type. That means this is made out of P-type material, right? P-type silicon or P-type germanium. And inside, because of the P-type, there are mostly holes, and the carriers are holes. So that means the gate will be the opposite. And in this side, see the left side and the right side, the two gate, the gate is N-type material, right? N-type silicon or N-type germanium. So now this is just opposite of the N channel. In case of N channel, this body was N-type and gate was P-type. And in this case, the body was P-type and the gate was N-type. And nothing else, exactly opposite. And the reaction of the operation is also will be opposite. You see, remember, in case of N channel, the source was electron, but in this case, the source was hole. Right? For p-type material, source will be hole. So that's why you see this. So in here also they are putting the source in the bottom. In here is a source. So source will be connected to positive terminal in here. What it says. This is not right, right? They say they put it the wrong symbol here, right? It says the positive will not be that side, and the negative in this side. So this is a source. So from the source, the current will flow from source to drain, or the holes will be flowing from source to drain, right? Where the source will be, or where the holes coming from? Positive or negative?
Positive, sir.
Positive. So that means এটা positive হবে. This one is not negative. এটা উল্টা দিয়ে ফেলেছে. Here will be negative, right? So then the holes will be coming from here and will go here and will come out from here. And this is the flow of hole. And current, how the current will flow? What will be the direction of the current? Is it opposite to the hole or the same direction of the hole?
Sir, opposite to the hole.
No. Opposite to the electron. Current, the direction of the current is opposite to the direction of electron, but not for the hole. Current is in the same direction with the hole. So the current also flowing in the same direction in here. And you see here is mentioned here, ID.
Yes, sir, এখন বুঝতে পারছি।
Right. Current and holes are flowing in the same direction, but the current and electrons are flowing in the opposite direction. Right? Because holes always attract the electrons. Right? That's the electron. If the electron flows this way, so the current means actually the holes will be flowing in that way, right? But they are trying to, right, attract each other. So that means the current will flow in this direction. This is a current. Now you can see the current and hole in the same direction, but the current and electron in opposite direction. Right? Any question? Any confusion? Okay, now, so you see exactly the same way. So the holes are flowing in this direction, and the high voltage is, so the voltage is higher in the bottom side, the source side is voltage is higher, and the voltage is lower in the upper side, in the lower side. And what about here in the gate? Look at this. It says a BGS, because as a gate voltage is positive. Here you see gate voltage is positive, so that means the positive voltage is applying at the N terminal here, positive voltage at the N, and here is a positive voltage at the P, and on the other side you see the negative is applying to the, in here you see the battery negative terminal is connected to the body, right? And in here is a positive. So in this case, in the lower side is more positive, and upper side is less positive. So that means the difference between the voltage will be more in the upper side than the lower side, and the depletion region will be almost the same shape as the N-type JFET. Right? It was very similar to the N-type. The upper side will be bigger, but and the operation is operation. So the polarity, you see, all are opposite, and body is p type, gate is n type, and the voltage also connected to the opposite direction. And in here gate voltage is positive, but the other one was gate voltage was negative, right? So the everything will be opposite direction, and the characteristic curves also will be opposite. You see, this is the characteristic curves. If we draw just only one of these, and if I can draw only one, and let's say here, let's say here, and let's say this is x and y axis, and I can draw. So the characteristic curves will be this one, right? This was the for the n type, and in here this one very similar like this. What about the p type? P type is it will be opposite. It will be here like that, opposite. This one should. Oh no, this one is not right. This one is not good. Mhm. This one will be here. This one will be like this, the opposite one. And this one, let it smooth away, like this one should be smoother. And in here, this is a positive for n type, this is for n JFET, and this is for P. And this is for P type. But in here, look, in here, they have drawn, okay, what they did, you can make this one mirror, right? If you take this one mirror, then it will go to this coordinate, and turns like this, right? Let's say this is a mirror, and so this diagram is going to, and you see this scale, you see here, minus 10, 5, 10, 13, 14, you see. But in here, I am considering this is a 0, this is positive, and this is negative. And left side negative, right side positive. Right? If you draw with this, this is the best way. And these people, this writer, actually doing a little bit opposite direction, right? They put a negative scale in the right side, negative scale should be in the left side, right? So anyway, and this, and this is the characteristic curves, right? But and now we'll see what we need. Oh, and this one also both has the same thing, right? The saturation. Okay, I use my curve, right? The both one has the saturation current in here. You see, this will be the saturation current, and this will be the pinch of voltage, right? Okay, here's this one. So this will be the pinch of voltage, just like this one, and this was what else? Yeah, and this was the saturation current, and this one in here is the saturation current. And for NMOS and PMOS, it will be just opposite. Right? We have to solve some mathematical problem, so we need it. Okay, now symbol, right? Because when we will be doing, when we will design this is a physical, right? It's a physical diagram. The actual diagram is this, but when we do the mathematical problem, or we write something, uh, or we want to show this what is called this is NJFET and PJFET. It is very hard to draw. This is complicated diagram on in his time. So that's why it has a symbol, just like the BJT. So this one has a symbol, and it is very similar, almost similar to BJT. And but this one has, you see, this instead of putting a diagonal line, they are putting a horizontal and vertical line only, right? And in the base, you see in here there is a connection here. There is the arrow, right? There is the arrow connection, and this is for N type JFET. And if you see the P type, in case of P type JFET, this arrow will be in the other direction. This arrow, okay, we should see that symbol. Here you see the arrow in the outward direction. So this is the P type JFET, and inward direction. Maybe there is a summary somewhere. Oh, here. All are. All the summary should be somewhere. Okay, then I don't find it. Anyway, don't worry. So this will be opposite direction, right? The symbol. But next time when we draw the circuits, we'll be using the symbol instead of just like remember that we in the PNP and NPN, the direction was opposite, right? In here, the direction was opposite, but in this case, the direction of the gate is opposite, right? For N type and P type, this is N channel, and when you have a P channel, this direction will be in the other way. And okay, now this is the formula. This is interesting. We need this one. This is very important formula. And ID is equal to IDSS into 1 minus VGS divided by VP whole square. So by using this formula, we can calculate the current at any point corresponding to some pinch of voltage or corresponding to some what's called saturation current, right? So many things we can calculate, or even we can calculate the ID for corresponding to VGS or corresponding to VP, right, by using this formula. So the value of ID, this is the graph, this is another graph. Okay, now okay, maybe this is a new for you. You have not heard about this one. We have seen this, the right side graph so far, right? This one, right? This one you have seen so many times before. This is called characteristic curves, right? IV characteristics, because this one is I, y-axis I, and the z-axis, no, x-axis is V. This is V, and this is I. So this is called characteristic curves, and sometimes we call it IV characteristics. IV characteristics, right? Sometimes we call it. But there is another curves here in these topics is known as transfer curve. Transfer curve is a little bit different, but it's coming from characteristic curves. And here you see, how do we do that? You see, graphically we can represent, yes, for this course, sometimes we need a graph. And most of the times for solving a problem, we need a graph paper. But I will supply whenever you need for quiz or test final. So this is here. Let's say the right side is already there, and the left side, the transfer curve actually is coming from this IV characteristic curves. Is from right side. Is coming from right side. How to do that? You see here, the first thing is when you have a VGS equal to 0, so corresponding to IDSS, you go and extend this value, right? Extend here and then get this point. In the same way, you extend this one and go here and then you find this point. And from this curve, you find this one, right? And from, right, gradually you decrease the VGS and you find several curves and then extend the saturation current, right? In here, this is the value of saturation current, and if you extend this line and wherever you get, right, and You see? No, okay. Maybe I did not explain clearly. First, what we need to do, extend this line here, right? This VG is equal to -1 and extend this up to this. And then in here, it's a VG is equal to -1. So now get it -1, and this is a 0, and this is -1, -2, -3, -4, and busiest in this, right? Busiest in this direction. Now take a -1 point here and go upward to the -1, and then here, and it will get intersection point here. Same way, this is a BG is equal to -2. So BG is equal to -2 is this point. You take a vertical line and extend this horizontal line here, and then you get this point, right? Extend this point here, and that is corresponding to BGS equal to -3. So BGS equal to -3. So you extend a vertical line, then you get a point. And this is the BGS equal to 0. So this is a BGS equal to 0 point, and extend here and extend this point. So now we got this point. Now we'll connect this one, right? Do you understand how you get the transfer curve? Do you understand that? Any question? No question? Huh? Are you here? Oh, no,
No,
yeah,
sir,
yeah.
no question.
Oh, you understand, right? So you
Yes,
have
sir,
you have to
understand.
do this, right? So you know, next time, no, what maybe some quiz, you have to do it, right? Manually, we need to extend here, and the corresponding BGS, and then find the transfer characteristic curves. Okay. Oh, in here they said how to do the plot transfer curve. Yeah, you already mentioned, right? Is solving for VGS equal to 0, IDS equal to ISS, solving for VGS, ID, use this formula, right? This is a universal formula, and solving for this, and then put it on the sheet, and then get the curve. And there is some summary. This is okay. When you go and buy a JFET from the store, then you will get this kind of sheet, right? This kind of specification, or quick. Sometimes we call it white page, and there are a lot of informations there that what is the operating range, and you see the maximum how much current will be flowing, and how much voltage it can tolerate, right? So there are some stuffs, and the symbols, how you see these symbols, and there are different configurations are there, this N channel, and what's the company, and which terminal is drain, which is gate, right? And the operating
স্যার
temperature
দুইটা কি
range,
সেম জিনিস?
right? This one.
দুইটা কি সেম?
No, this is one company, and this another company. Like some company are making like this one. This is 3 terminal. This is a gate, drain, source, and this one also is a gate, drain, and source, right? And different company making in different way. You see in here, gate in the left side, source in the middle, drain in the right. But in here is the opposite. This one looks like an IC, right? And this one name is here. You see the different name. And if I no, this is a 2 different company. No, it's a fair side. Okay, same company, maybe they are making for 2 different region. In most of the cases,
স্যার
they are making
এগুলো কি
one for
আলাদা
low
কাজের
power,
জন্য আর দুইটা সেম কাজ করে?
and yeah, same কাজ, but অনেক সময় power range এর উপর depend করে. This device is a low level audio amplifier and switching transistors, and can be used for analog switching applications. Source and drains are interchangeable. Oh yeah,
ওকে
source and
স্যার।
drain, আমরা তো বলেছি source and drain is আসলে same thing.
স্যার আমাদের এখানে বাংলা মিডিয়াম বেশি, যদি স্যার আপনি বাংলা ইউজ করতেন আমাদের আরেকটু ভালো হতো।
তাই নাকি?
জি স্যার।
লাস্ট সেমিস্টারে আমাদের আরো ঝামেলা করেছে তো। লাস্ট সেমিস্টারে বোধহয় ইংলিশ মিডিয়াম স্টুডেন্ট বেশি ছিল। তারা বলে যে স্যার বাংলা বললে স্যার অনেক বুঝতে পারতে অসুবিধা হয়। Oh, no, I can do anything because আমার আসানুল্লাহর স্টুডেন্ট বেশিরভাগই বাংলা মিডিয়াম, আমরা বাংলাই বেশি বলি।
জি স্যার, আপনি বাংলায়
Okay.
বলেন, প্রবলেম নাই।
কতজন আছো ইংলিশ মিডিয়ামের? বাট তোমরা বাংলা বোঝো ভালোই, তাই তো?
স্যার বাংলা
জি
বললে
স্যার, বাংলা
প্রবলেম
আমরা
নেই স্যার,
ভালো
ইংলিশ
বুঝি।
মিডিয়াম আর বাংলা মিডিয়াম
Okay.
ডাজন্ট ম্যাটার।
স্যার বাংলা সবাই বুঝে স্যার, এটা ইজিয়ার হয় বোঝার জন্য আর কি।
ও না, লাস্ট সেমিস্টারে বোধহয় একজন না দুইজন তারা বোধহয় ভালো বাংলা পারে না, তারা ইংলিশ বলতে গিয়ে, আমি তো তখন ফেস টু ফেস ক্লাস নিতাম, তারা বলছে যে স্যার একটু প্রবলেম হয় স্যার, কারণ বইতে পড়ে আবার ইংলিশে তো। ওকে, ও এর ব্যাটারি হচ্ছে, ওকে মেবি আমাকে ক্লোজ করে তো, আমার ব্যাটারি লো দেখাচ্ছে আর আমি একটু আগে বেরোতে হবে। সো উইল লিভ, মেবি দিস টপিকস ইজ অ্যাকচুয়ালি ডান অ্যান্ড টেস্টিং আমরা নেক্সট টপিকস হলো মসফেট। ওকে, উইল স্টাডি মসফেট নেক্সট ক্লাস। ওকে, আমরা যে ফেটটা আমরা শেষ করেছি, যে ফেটের কিছু প্রবলেম করবো না, তার আগে আমরা মসফেট একটু পড়ে তারপর আমরা ম্যাথমেটিক্যাল প্রবলেম সলভ করবো, right? And then we need a whiteboard. I will use the whiteboard from next class, and I'll go back to Dhaka soon, and then we'll see you. Right? আমি তাহলে আজকে এখানে স্টপ করছি। এনি কোশ্চেন এই পর্যন্ত? তোমাদের কোশ্চেন থাকলে করতে পারো। ব্যাটারি লো, নট আমার এখানে কানেকশন এক্সটেনশন
স্যার আজকে ক্লাসের
প্রবলেম
রেকর্ডিং
হচ্ছে।
দেখে হয়তোবা
I
নেক্সট
know.
ক্লাসে কয়েকটা কোশ্চেন্স থাকতে পারে।
হ্যাঁ, নেক্সট ক্লাসে আমি বাসায় থাকবো, অতএব হ্যাজ নো লিমিটেশন।